Welcome back. This is Professor Ridge and today's lesson on 7.1 radical expressions and functions. So we're going to start off with square roots and the definition of square root. Okay, so the definition, the number c is the square root of a if c squared equals a. So, example, if I ask you what's the square root or the square roots, because there's more than one, of 9, you're going to say, well, 3 is the square root of 9 since 3 squared equals 9, and negative 3 is also a square root. Since negative 3 squared equals 9. So you have two square roots. So the square roots of 9 are 3 and negative 3. So you got both of them. Okay, so since each positive number has two square roots, one positive one, one negative one, we like to be a little more precise, so we have what's called the principal square root, and it's the principal square root of a non-negative number is its non-negative square root. So for example, if I asked you the principal square root, that's the symbol, okay, so of 9 is the positive square root of 9, which is 3. Okay, so if I want the negative square root, okay, so this radical sign stands for the principal square. We never say principal square root, but it stands for the principal square root. You'll never hear anyone say, what's the principal square root of 9? But that's what the radical sign represents. Okay, so if you want the negative square root of 9, we put the negative symbol in front, or the opposite sign in front of the square root. So this is the opposite of square root of 9. And again, it's the opposite of the principal square root of 9. But again, no one ever says that. We understand that the square root symbol stands for the positive one, and then the negative in front of that, or the opposite in front of that, would mean it'd be negative 3. Okay, so that way we can have a little more precise way of asking for answers for square roots. So the principal square root is the radical sign, and we don't. You'll never hear me say the principal square root unless I'm trying to emphasize the sign. All right. So now what's the what is the square root according to our first definition up there? Square root of negative 4. And the answer is, so I want to know what squared equals negative 4. And the answer is nothing. No real number squared. Remember, anything squared is going to be positive. So this has no real solution. Right? So the square root of principal square root of negative 4, or even just the square root of negative 4, you can't do it. It's not real. And at the end of this chapter, we're going to learn about imaginary numbers. So if it's not real, it's imaginary. Okay? So if you have a negative inside the square root, it's not real. You can't do it. Not yet, at least. It's not defined. And again, later we will define it, but for right now we just say not real. Okay, so let's just practice simplify. What's the square root of 144? So what times itself? So it's 12. And remember, it's the positive one, because that's what the radical sign stands for. How about negative square root of 100? So again, we take the square root of 100, which is 10, and then we want the opposite of that, so this is negative 10. Then number 22, square root of 4/9. Well, that's going to be 2 times 2 is 4, 3 times 3 is 9, so it's 2/3. Okay, so this next thing here, simplifying square root of a squared. For any real number a, the square root of a squared, again the principal square root of a squared, is the absolute value of a. And this is confusing for a lot of people at first because remember again, what we're doing, if I gave you a whole bunch of problems and I said, okay, what's the square root of 5 squared? Well, you'll say 5 squared is 25. Square root of 25 is 5. Square root of negative 5 squared is square root of positive 25, which is 5. So you see here, if you just said the square and square root cancel each other and you would get negative 5. But we already defined this symbol as the principal one, so it would be positive 5. So see, if we square first, we lose the sign, we get positive 25. And then the principal square root of positive 25 is positive 5. So if I did x squared, it's not x, square root of x squared, it's not x, it's the absolute value of x. Alright? So you just have to be careful. Alright, so now on to cube roots. So the cube root is basically the same idea. So the number c is the cube root of a if c cubed equals a. So there's that same thing. So now we're gonna, instead of square root, we're doing cube. So this would be c cubed equals a. So it's the reverse of cubing, cube root. And our symbol is going to be the radical sign. We put a little 3 up here. This is called the index. And of course the number inside is still the radicand, just like with square roots. I think I forgot to write that before. And then you have the radical sign. Okay, so what is the cube root of 125? So we're saying what to the third power, and it's 5. We're saying 5 to the third power is 125, so 5 is the cube root of 125. What's the cube root of 8? Well, 2 cubed is 8, so 2 must be the cube root of 8. How about cube root of negative 216? Well, negative 6 cubed is negative 216, so this equals negative 6. Now notice, with the odd index cube root, right, if we do negative 6 to the third power, that's negative 6 times negative 6 times negative 6, you get a negative 216. So it's okay to have negatives inside cube roots. And it turns out inside any odd power index, it's fine to have negative inside. And then we can generalize it to any power, so nth roots. So it's the number c. So just change the cube to n. Okay, so the nth root of a, again, so the index tells us the power, and then a is still the radicand. The number inside is still the radicand. Okay, so if I want you to simplify, the, say, fifth root of 32, we're saying what to the fifth power equals the number inside 32? The answer is 2. What to the fourth power is 81? That's 3. Okay, so for odd powers you can have negatives inside. Even powers you can't have a negative inside, so that's no problem. So if I asked you what's the sixth root of negative 128, and the answer is it's not real, because you can't have something to the sixth power equal to a negative number, right? So you can't ever make that a true statement, so it's not real. Okay, so just to generalize on what we talked about earlier about the square root of a squared, if it's an even index, so if the nth root of a to the n is just a if n is odd. So if that number is positive or negative, it doesn't matter. You get a positive or negative number out here. So an example, if I did the cube root of negative 5 cubed, that's going to be negative 5. But if I did the fourth root of negative 6 to the fourth, that's going to be the absolute value of negative 6, which is 6. Because when I raise negative 6 to the fourth power, I'm going to get a positive number inside, and then the fourth root of that will be a positive number. Okay, so if it's even index, it's the principal square root, which is the positive one. If it's an odd one, there's only one nth root anyway. So if it's an odd index, it's just the number itself. If it's even, then it's going to be the absolute value of the number. Let's look a couple from the book. So this is number 58. It just simplify. We got the fifth root of a the fifth. So since those are odd indexes, it's just a. So for 60, fourth root of 7b in parentheses to the fourth power. So again, these are even, so I need the absolute value of 7b. And the absolute value of 7 is just 7, so we can bring that out. But the b has to still be in parentheses. I mean absolute value. Okay. So let's look at 66. I want the square root of x to the 10th. Now this is going to be, now what squared is x to the 10? So basically what you do is you divide by 2, that's x to the 5th. See, that's x to the 5th squared. So the square root cancel each other, and since x to the 5th is odd power, I need to put absolute value around it because it was an even index. Square root's even. So my rule of thumb for this, if it's an even index, even power inside, so it's square root of x to the 10, and the answer comes out odd, you need the absolute value. So let me write down. Let me show you a couple more on the next page. Okay, so square root of x to the 6. So you're going to do, basically you're going to do 6 divided by 2 is 3. So that's going to be x cubed squared. So we get x cubed. And that needs an absolute value. And what I was talking about before, if you have an even index, an even power before you divide by the 2, and then when you divide, if this comes out to be an odd power, then you need the absolute value. If it comes out to be an even, then you don't need it. So it's even, comes out odd, you need absolute value. Any other case, you won't need it. So if I had square root of x to the 16, 16 divided by 2 is 8, and since it's even, comes out even still, I don't need the absolute value, because if x, here's the reason, because if x was a negative number to an even power will be positive anyway. So the idea is we're making the absolute value to guarantee that the answer is positive. If it's an even power, that makes it positive. So if I had 3x to the 15, so I do 15 divided by 3 is 5, and see it's odd, comes out odd. I don't need the absolute value. Only when it's even, comes out odd. So let me do one more. So if I do 4th root of x to the 28, so I do 28 divided by 4 is 7, and see I had even, comes out odd, so I need the absolute value. Alright, so hopefully you get that. And then what happens is then it gives you like 69 on. It says assume that no radicands were formed by raising negative quantities even power. So they're just saying that you can ignore using the absolute value, just so you can focus on simplifying these things. Alright, so that concludes the lesson for 7.1. Go to My Math Lab and complete your exercises there, and I'll see you next time.